Let us continue our discussion on Chebyshev low pass filter. Okay, so now we are going to discuss the magnitude function. Okay, so the magnitude function of a Chebyshev filter is given by capital A divided by square root of 1 plus epsilon squared Cn squared of omega divided by omega p. Okay, so this is HA of j omega magnitude squared, where epsilon is a constant, right, and capital A is also a constant, and then this capital N is the order of the filter, and let me call this is equation number 1, and this equation 1 is the form of the magnitude function. Now if you, I'm sorry, this is magnitude. If I square this magnitude function HA of j omega, square it on both sides, then it would be 1 divided by 1 plus epsilon squared Cn squared of omega by omega p. Okay, now this C suffix capital N, that is Cn of x, we call Chebyshev polynomial. Chebyshev polynomial, where I assumed this omega by omega p is equal to x. Therefore, the Chebyshev polynomial is defined as cosine of n cosine inverse x for mod of x less than 1. Okay, that is x lies between -1 and +1, and when x exceeds 1, then the cosine function and the cosine inverse loses its meaning. Okay, especially cosine inverse loses its meaning. Therefore, we have to replace cosine by cos. Okay, when the x value exceeds 1, then the cosine inverse of x loses its meaning. So it is meaningless to write the same formula when x is greater than 1. Okay, and therefore this cosine inverse and cos both has to be replaced. So in this case you have to replace cos function by cos. So this is the natural transition. So in this case, instead of cos, I have cos, hyperbolic function, cos of n cos inverse x, okay, for mod x greater than 1. Now we know that cosine function is oscillatory. Okay, so this is oscillatory, and this cos of n cos inverse x gives rise to oscillations. Okay, since it is oscillatory, it gives oscillations or ripples. Okay, that is why we have seen in the passband there are ripples, if you recall, like this. So this is omega p. Okay, so in this region your mod of x is less than 1. Why? Because we assumed omega by omega p is equal to x. So here in this range your omega is going to be less than omega p, isn't it? So omega is less than omega p, therefore omega by omega p is less than 1. That means what? Mod of x is less than 1. That is why we got oscillations in the pass band because of this cos functions. Okay, so you got oscillations or ripples in the pass band for mod x is less than 1. That is, when I say mod x is less than 1, that means your omega is less than omega p. When I say omega is less than omega p, that means I am talking about the pass band. Okay, so that means what? We are talking about minus omega p to plus omega p, but since it is real, we are talking about the positive frequencies only. We are not considering about the negative frequency, because we know that the magnitude function is what? It is an even function. If you know the behavior of the function from 0 to omega p, then it's very easy to construct from minus omega p to 0. And therefore it suffices to consider 0 to omega p, no need to consider minus omega p to plus omega p. So mod of x is less than 1, that means omega by omega p modulus is less than 1. So magnitude of omega is less than magnitude omega p, that is minus omega p less than omega p. Okay, and for mod x greater than 1, that means what? This is omega p, and this is a region where omega is greater than omega p. So when I say mod x is greater than 1, this implies my omega is greater than omega p. Mod of omega is greater than mod omega p mod. That means what? We are talking essentially about the stop band. Okay, so in the stop band, the cos function, in the stop band we gave the expression cos, hyperbolic function. Therefore in the stop band the function is monotonic, and therefore the magnitude characteristic will be monotonic beyond the pass band. So this is pass band and this is stop band. In the pass band we have cos of n cos inverse x. In the stop band we have cos of n cos inverse x. As I said, in the pass band we have oscillatory behavior in the pass band, and then it is monotonic in the stop band. Therefore beyond the stop band the characteristic would be monotonic. In pass band it will be oscillatory. Okay, so beyond the pass band it will be monotonic, which is the characteristic of the Chebyshev filter. Now let us get familiarized with this Chebyshev polynomials. Now Cn of x, this we know the general relation. What is the relation? Cos of n cos inverse x, where mod x is less than 1, and cos of n cos inverse x for mod x greater than 1. Now you substitute n equal to 0. So C0 of x. Okay, so in this case cos of 0, so this is 1. Now substitute n, capital N equal to 1. So C1 of x is equal to cos inverse of x. So this is x. C1 of x is x. Okay, now substitute n equal to 2, then C2 of x is equal to cos of 2 cos inverse x. Now in order to find out this expression, let us put cosine inverse x equal to theta. Then this is cos of 2 theta. Okay, so C2 of x would be cos of 2 theta, and then this is 2 cos squared theta minus 1, right? Now what is cos theta? Cos theta from this x is equal to cos theta, so 2 times cos theta is x, so cos squared theta is x squared, so 2x squared minus 1. Therefore C2 of x is 2x squared minus 1. Okay, because ultimately our interest is in the variable x, that is why I brought back to x here. Similarly, C3 of x, which is cosine of 3 times cos inverse of x, again substitute cos inverse of x equal to theta, so cos 3 theta, and then this is 4 cos cubed theta minus 3 cos theta, and then cos theta is x, so 4x cubed minus 3x. This is C3 of x, because here we substituted cos inverse x equal to theta, x equal to cos theta. Okay, so cos cubed theta equal to x cubed, that's it. Okay, so let us list out the expressions. C0 of x equal to 1, then C1 of x is equal to x, and C2 of x is equal to 2x square minus 1, and C3 of x is equal to 4x cubed minus 3x. Now does that mean that we will have to remember all the multiple angle formulas? No. Okay, we can find a recurrence relationship. With that you can easily write down the Chebyshev polynomial. So now let us try to find out the recurrence relationship. For Chebyshev polynomial. Okay, so the recurrence relationship comes from this: cosine of n theta plus cosine of n minus 2 theta is equal to 2 times cos theta cos of n minus 1 theta. Okay, see, if we apply the trigonometric formula, I mean cosine A plus cosine B is twice cosine of A plus B by 2 cosine of A minus B by 2. That formula you can use it. So here this is A and this one is B, therefore this is 2 times cosine of A plus B, that is n theta plus n theta minus 2 theta divided by 2 times cosine of A minus B. So n theta minus n theta plus theta by 2, sorry, plus 2 theta. So therefore 2 times cosine of n theta plus n theta, 2n theta minus 2 theta, that is n minus 1 times theta. Okay, then this one is going to be cosine of n theta cancels, so 2 theta by 2 theta. And we know that therefore cosine of n theta is nothing but Cn of x. Okay, so this one is Cn of x. On the right hand side you got this expression, and the left hand side cosine of this is n theta plus cosine of n minus 2 theta. Now cosine n theta is equal to Cn of x. What is Cn of x? Cn of x is cos of n cos inverse x, right? That's what we defined in the beginning. Now cos inverse of x equal to theta, right? So cosine of n theta. So Cn of x is cosine n theta. Now instead of n, I have n minus 2 here. Therefore this whole expression is going to be, this whole guy is going to be Cn minus 2 of x. And this one is going to be, sorry, I beg your pardon, Cn of x plus. So what is there in the right hand side? This one. Let me use some other color. The right hand side 2 times cosine of I'm sorry, not cosine, 2 times cos n minus 1 theta becomes C n minus 1 of x, and then this cos theta becomes x. So the right hand side you have 2x Cn minus 1 of x. The left hand side Cn of x plus Cn minus 2 of x. Okay, now let me take this quantity to the right hand side. Therefore Cn of x is equal to 2 times x c suffix n minus 1 of x plus Cn minus 2 of x. So this is the recurrence relation. Okay, for example, if capital N is 3, then C3 of x is equal to 2 times x, then 3 minus 1 2, C2 of x plus C1 of x, and this we already calculated. Okay, C1 of x is x. I'm sorry, I did a mistake. This is going to be minus because it goes to the right hand side, right? Minus. Now 2 times C2 of x. What is C2 of x? C2 of x is 2x squared minus 1. C1 of x is x. Therefore 2 times 2 4, 4x cubed minus 2x minus x. So this is 4x cubed minus 3x, which agrees with the previous result. In a similar way, you can find out C4 of x. C4 of x is again 2x times C3 of x minus C2 of x. And then 2x times C3 of x is this one, 4x cubed minus 3x minus C2 of x. What is C2 of x? 2x squared minus 1. So this is 8x to the 4 minus 2x, 3x, it is 6x squared minus 2x squared plus 1. So this is 8x to the 4 minus 8x squared plus 1. This is C4 of x. Okay, therefore C4 of x is equal to 8x to the 4 minus 8x squared plus 1. Now you notice the pattern. Okay, C0 of x is 1, C1 of x is x, C2 of x is 2x squared minus 1, C3 of x is 4x cubed minus 3x, and C4 of x is 8x to the 4 minus 8x squared plus 1. Now if the order is odd, that means 1, 3, 5 and so on, then the polynomial itself is odd. Okay, this is odd polynomial and this also odd polynomial. C1 of x is x, C2 of x is 4x cubed minus 3x. So these two are odd polynomial. On the other hand, if the order is even, like 0, 2, 4 and so on, then the polynomial is even. See, look at this guy, this one and this one and this 3. Now the polynomial itself is an even polynomial. Power is even, 8x to the power 4 minus 8x squared, and here 2, and here this x to the 0, you can write like that. Therefore even polynomial. If the order is even, the polynomial is an even polynomial. If the order is odd, then the polynomial itself is an odd polynomial. Okay, and you notice that Cn of 0, substitute x equal to 0. Okay, so let me make some space here. Okay, now you notice that Cn of 0 is equal to, or has to be equal to 0 when n is odd. Okay, in this case it becomes 0 and here also it becomes 0, because Cn of x is the odd polynomial for capital N, odd. So this point you have to remember. And Cn of 0 is equal to either plus 1 or minus 1 if n is even. In this case it is 1 plus 1, and in this case it is minus 1, and here it is plus 1. So whenever the order is even, then Cn of 0 is either plus 1 or minus 1. Therefore Cn of 0 is equal to 0, n is odd, and equal to plus 1 minus 1, n even. Okay, because C2 of 0 is equal to minus 1, but C4 of 0 is plus 1. So it is either plus 1 or minus 1. Okay, therefore we learnt two things. One is that if capital N is even, the polynomial is even. If capital N is odd, the polynomial is odd. And because of even and odd characteristic, the behavior at x equal to 0, see, when I say Cn of 0, what does it mean? The argument is 0, that means x equal to 0, right? So when x equal to 0 means what? We assumed omega by omega p is equal to x. That means omega is equal to 0. Omega is equal to 0 means what? We are talking of DC point, DC characteristic. Okay, so at 0 frequency, what is the characteristic? What is the value of the Chebyshev polynomial? Okay, so the value is either 0 or plus 1 or minus 1, depending on whether capital N is odd or even. Okay, so when I say x equal to 0, then the Chebyshev polynomial will be either 0 or plus minus 1. Now a picture is a better way or better indicator of this property. Okay, so let me draw a picture. So let me draw a square. 1 2 3 4. Okay, 1 2 3 4. Maybe I will make it a little bigger. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Is it a square? No. 1 2 3 4 5 6 7. Okay, this side. Okay, so it looks like something. Fine. So let me draw a figure square and divide into 4 equal parts. Again I did a messy thing, so 1 second. So now I have done a bigger square. 1 2 3 4 2 3 4 like this, and like this, 4 equal parts. Now we plot Cn of x in this direction and x in this direction. Okay, so this point is minus 1, x equal to minus 1, and this is plus 1, center point is 0, and Cn of x is plus 1 here, minus 1 here. Okay, now what is the C0 of x? C0 of x is equal to, if you look at, we have done that. Okay, it's a 1 constant. Okay, so it is 1. Therefore C0 of x will be like this. It's a pink color. I don't know what color this is. This one. Cn of 0. And then the next one is C1 of x. What is C1 of x? C1 of x is x, and therefore it is a straight line. Maybe use some other color. It is a straight line passing through the origin. Therefore it goes like this. So this is Cn of C1 of x, C0 of x, and this is C1 of x. Now C2 of x. What is C2 of x? C2 of x is 2x squared minus 1, and therefore it starts from plus 1. Okay, and this point is a plus 1. C1 of x is plus 1 when x equal to okay, this point is minus 1. So yes, okay, so you substitute x equal to minus 1 in this, then minus 1, then C2 of minus 1 is equal to 2 times of minus 1 square minus 1, so this is 1. Therefore it starts from here. When substitute x equal to 0, it is minus 1, so it comes like this and goes like this. It's a kind of parabola. Okay, this is C2 of x. And the next one is C3 of x. You substitute x equal to 0 in this expression. X equal to minus 1, x equal to 0, and x equal to 1. When x equal to 0, you'll get minus 1. When x equal to plus 1, again you'll get plus 1. So you connect these 2 points, then it goes like this. It comes. Okay, so this green color is the C2 of x. Similarly, you can draw C3 of x also. C3 of x is equal to 4x cubed minus 3x. At x equal to 0, C3 of x is equal to 0. And when x is equal to minus 1, then C3 of x is minus 1. So it starts from it starts from minus 1. Okay, and then it must pass through 0. Okay, therefore let me draw one more, because it is over congested. So let me draw one more box like that. Like this. Okay, so therefore it starts from minus 1. Okay, so this point is minus 1 and it reaches maximum and again passes through 0, comes down, and again it reaches the maximum value, because when x equal to plus 1, then C3 of x is plus 1. So therefore this is C3 of x. Okay, similarly C4 of x is 8x to the 4 minus 8x squared plus 1. When x equal to minus 1, then C4 of x is plus 1. When x equal to 0, then C4 of 0 is 1. Then x equal to plus 1, then C4 of plus 1 is equal to again plus 1. Okay, that means this plot, it starts from here and again it reaches this point and reaches this point. Therefore in between there is a minima. Okay, so therefore C4 of x starts from here, goes down and comes like this. Okay, color is not that much great. Okay, okay, when x exceeds, let me complete this, and then comes down and again comes like this. Now if you take this point, okay, let me call these 2 points. Beyond this point and this point, let me use some other color. These 2 points, let's say this point is A and this point is B. or 1 second, let me draw one because it is too congested. 1 2 3 4. For example, if you take a C3 of x, the C3 of x looks like this, and now let me take this point and this point. Let's say this is A and this point is B. Now this is x, and this one is Cn of x, and x is equal to -1 here, 0 and +1. Now if you go out of this point B, that means what? You are exceeding the value of 1. X is greater than 1. So when x is greater than 1, we said the Chebyshev filter has the characteristic of monotonic. Therefore you may not have this kind of ripples, but beyond x it is monotonic. Okay, it goes like this. It is monotonic when x is greater than 1, mod of x greater than 1. That means what? Even if you go this direction also, again monotonic. That's what we mean by this one. That is -1 is less than -x. Therefore the equal ripple oscillation is obvious from here between x equal to -1 and +1. Now our concern is between 0 and +1. We only consider positive frequencies, and the positive frequencies are 0 to 0 and above. Okay, and 0 for x will correspond to capital omega. Capital omega equal to 0, right? When I say x between 0 to 1, that means omega by omega p corresponds to 0 to 1. That means when omega is omega by omega p is equal to 0, it implies omega is equal to 0. Okay, so that means when I say x equal to 0 correspond to omega equal to 0. So omega equal to 0 means DC value, and therefore if we consider the transfer function HA of j omega magnitude is equal to A divided by 1 plus epsilon squared Cn squared of omega by omega p to the 2n. Why did I put a 2n there? I'm sorry, this 2n will not come here. Have I done the same mistake in the beginning of the lecture also? No, thank God. Here this is A actually, I'm sorry, it's a constant, right? Okay. Okay, and then square root, let me write down the square root as 1 by 2. Okay, so now what is the maximum value of this magnitude? Maximum and minimum value, let us find out. Okay, so the maximum of magnitude of HA of j omega will obviously lie between two maxima for mod omega less than omega b, because it is oscillating, right? In the pass band it is oscillating like that. So therefore it should have this point and this point. It lies between these 2 points. Now let us consider what is the maximum value and what is the minimum value. So if you consider in the pass band, the range is 0 to omega p. The Cn of x is oscillatory. Now the question is, what is the maximum value of Cn squared of omega by omega p? And what is the minimum value of Cn squared of x? And as I said, this Cn of x will be either 0 or plus 1 or minus 1. Now among this, what is the minimum value? Minimum value is minus 1. Okay, but we don't want Cn of x. What we want is Cn squared of x. Now if you square it, 0 plus 1 plus 1. Now what is the minimum value in this? The minimum value is 0. And the maximum value is 1. See, if you take Cn of x, then this is the minimum value. If you take Cn squared of x, then this is the minimum value. 0 is the minimum value. Now in this expression, we need Cn squared of x. Therefore, the minimum value is 0. So in that expression, a divided by 1 plus epsilon square times 0, therefore it is a. Therefore HA of j omega is going to be a. And then this is a case when Cn of omega by omega p is equal to 0, minimum value, when this is minimum and this will be maximum. Now when Cn squared of omega by omega p is equal to, let's say, 1 maximum value, then in this case HA of j omega magnitude is a divided by 1 plus epsilon squared times 1 by 2. So this is a divided by square root of 1 plus epsilon squared. Now my magnitude HA of j omega lies between these two values. Now which is bigger? A is bigger than a by square root of 1 plus epsilon square. Why? Because epsilon is less than 1. Okay, so obviously this quantity is lesser than a. So the magnitude HA of j omega lies between capital A and capital A divided by square root of 1 plus epsilon squared. Okay, so this is the lower limit and this is the upper limit or maximum value. The lower limit is obtained when Cn of x is equal to 1 and the upper limit is obtained when, am I correct? Yes, Cn of x equal to 0. Now if capital A is normalized to 1, then HA of j omega magnitude will lie between 1 and 1 divided by 1 plus epsilon squared. Okay, here capital A is taken as 1. Then the magnitude will lie between 1 and 1 by square root of epsilon square. Okay, now let us draw a few more pictures and then let's see. Okay, now 1 minute. So this is the pass band and my stop band starts from here, omega. This is omega s, omega p, and this is delta p, delta s, and then and this point is minimum value 1 divided by square root of 1 plus epsilon square, and the maximum value is 1 normalized to 1. So this is magnitude. Like this. So let's see capital N equal to 1. Okay, and this 1 is odd, right? So capital N is odd. If it is odd, then at omega equal to 0, this is a point where omega equal to 0, and when omega equal to 0, therefore the magnitude will be 1. Okay, so magnitude will be 1. So let me write down the function here. HA of j omega magnitude is 1 divided by square root of 1 plus epsilon squared Cn squared of omega by omega p, right? When omega equal to 0 for odd n, this magnitude becomes 1 for odd n, and therefore my filter starts from here and it goes like this. And this is for capital N equal to 1. Okay, it starts from this point and goes like this. Okay, now the answer should have been obvious. Why? Because first order filter, either Butterworth or Chebyshev, it is the same, because the transfer function is what? For first order filter, what is the transfer function? When I say n equal to 1, it is going to be you can easily find it. When I say n equal to 1, then 1 divided by 1 plus epsilon square C1 square of omega by omega p, and this is 1 by 2. Now what is C1 of omega by omega p? It is omega by omega p. Recall the expression or Chebyshev polynomial. C1 of x is x alone. So this is 1 divided by 1 plus epsilon square omega by omega p whole to the power 1 by 2. Okay, C1 of x is x, C1 squared of x is x squared. Therefore, this is omega square omega p squared. And then it is, now let us assume this 1 is very less compared to this omega by omega p. Okay, omega square by omega p squared. So I'm sorry, let it be I beg your pardon. So 1 divided by omega p squared plus omega squared by omega p squared whole part to the 1 by 2, and this is omega p divided by omega p squared plus omega squared whole power 1 by 2. This is the same as Butterworth filter, if you recall. Therefore, when capital N equal to 1, then the Chebyshev filter and the Butterworth filter are one and the same. It is the same. Okay, first order filter, either Butterworth or Chebyshev, it is the same, because the transfer function is omega p divided by s plus omega p. Okay, if you transform this into the s domain, then this becomes omega p divided by s plus omega p. Okay, now for the second order, obviously when n equal to 2, second order, obviously at omega equal to 0, Cn squared of 0 is plus 1. If this is plus 1, then you have 1 by square root of 1 plus epsilon square. Therefore, my plot starts from here, okay, and it goes like this. Let me use some other color. It goes like this and comes like this, goes like this. So this is n equal to 2, okay. It starts from this point, goes and reaches this point, and then again comes, and all curves passes through this point. This point is important point, 3 dB point, okay. So you notice that at omega equal to omega p, the Cn squared of omega by omega p is Cn squared of omega by omega p. If we substitute omega equal to omega p, then Cn squared of omega p by omega p, that is Cn squared of 1. Cn squared of 1 is always 1, because Cn of 1 can be plus 1 or minus 1, right? Cn of minus 1 can be plus 1 or minus 1, but Cn square of 1 is always plus 1. And therefore, irrespective of the order, all the characteristic must pass through this point. Whether you take n equal to 1, 2, 3, 4, doesn't matter, okay, because in this point omega is equal to omega p. That means Cn of omega by omega p, that's what we wrote here. Substitute omega equal to omega by omega p, then it becomes like this. Okay, Cn of 1, Cn squared of 1, and this Cn squared of 1 can be, see, Cn of 1 can be either plus 1 or minus 1. Similarly, Cn of minus 1 can be either plus 1 or minus 1. But the moment you square it, Cn squared of 1, then it is always plus 1. Okay, if this is always plus 1, then substitute in this expression. In this expression, substitute 1 here. Therefore, this expression is going to be 1 divided by square root of 1 plus epsilon squared. Okay, so therefore, at omega is equal to omega p, at this point the magnitude is 1 by square root of 1 plus epsilon square. So this is the point where the magnitude is 1 divided by 1 plus square root of epsilon square. And therefore, irrespective of the order, all characteristics must pass through this point, okay, like Butterworth filters. And this is the edge of the pass band, okay. So all the characteristics must pass through this point. In our case, this point magnitude is 1 divided by 1 plus square root of 1 plus epsilon squared. In Butterworth case, what is the magnitude? It is 1 divided by square root of 2. This is for Butterworth case, and this is for Chebyshev case. Okay, it is equal to 1 by root 2 if epsilon equal to 1. Now let us consider the next order. Like this, when I say capital N equal to 3, again 3 is odd, okay, therefore it must start from this point, and it goes like this and goes like this, touches this point. It has to pass through this point, so it must pass through another maximum here in this point, and so on, and goes like this. goes like this. Okay, this is n equal to 3. Now when I take n equal to 4, 4 is an even number, so it must start from this point. Okay, so it has to pass through this point, maxima, and another maxima here. Okay, and then again another maxima here, and then pass through this point. I'm sorry, this curve is very bad. I'm very sorry. Like this. Okay, so it proves one point, that is the number of peaks and dips. Peaks and dips in the pass band is exactly equal to the order. See, the red curve is n equal to 4. So 1, 2, 3 and 4. Okay, so there are 4 number of peaks and dips. Okay, when you consider either n equal to 1, you have only one peak here, that's it. Consider n equal to 2, then you have only 2 points. Okay, so considering omega equal to 0 as either a peak or a dip, because the function is even, and therefore it starts from here in this point and then goes to this point and this point. Therefore 4 peaks and dips. Okay, therefore this is a point of this also can be considered as point of maximum or minimum, because the magnitude is even, right? So therefore this point also a point of maximum or minimum, this point. Okay, so if you take capital N equal to 3, we have 3 peaks. See, this is 1 peak, 2 and 3 peaks. This green color is N equal to 3 peaks. If you take capital N equal to 4, we have 4 peaks shown in the red color. So the number of maxima and minima in the pass band is equal to capital N, is equal to the order of the filter. Therefore, number of maxima and minima in the pass band is equal to capital N. And if capital N is even, the starting point is 1 divided by square root of 1 plus epsilon squared. Okay. If capital N is odd, then the starting point is 1. Starting point means what? When I say starting point, that means omega equal to 0. Starting point means at omega equal to 0. Okay, so if you remember these points, then we can discuss or design the low pass filter using Chebyshev method very comfortably. Okay, so let me stop here. Okay, in the next lecture we will continue the 3 dB frequency of Chebyshev filter and so on and so forth. Thank you very much.